Brother Crook, are you talking? Because I'm not hearing anything. I think you're muted.
I was muted the whole time. Thank you. Okay, well, we're starting. Yes, I'm very glad you brought that up. I have a mute button on my mic that I clicked, but I didn't unclick the mute button in Zoom. Thank you. So for this week's video, we're going to, or meeting, we're going to cover both week 10 and week 11. And we're going to just kind of jump into the exercises. Good news is when I was meeting, you didn't miss much because just getting ready more than anything. But anyways, so we're going to start with week 10. Both the weeks are pretty light as far as like reading and all that. So I thought we'd just keep it nice and simple. I think the best way to kind of learn the case stuff and the transactions is actually just to see it in action. So that's kind of what we're going to do. We're just going to jump right into these exercises and a couple little additional examples along the way. So in your reading, you'll go over what's the difference between a searched case expression and a simple case expression. And to be honest, I've found, for the sake of building something that's future-proof, I hardly ever use a simple case expression, but we'll go over both. So anyways, let's take a look here. This is actually a simple case expression, or sorry, search case expression. So let's take a look. So you can see here that right now, this is selecting name from language. And basically what it's doing is it's getting what character set to use based on the language. So I'm actually going to rewrite this query since it's not going to copy paste well, and we're going to do this exercise together. So it says rewrite the following query, which uses a simple case expression so that the same results are achieved using a searched case expression. So real quick, while I'm writing this, just kind of want to go over what the difference between a searched case expression and a simple case expression is. So a simple case expression is, I don't want to use the word simple, but it's just simpler. That's where it gets its name. So we're going to first start off selecting the name of language. And then we're going to write our case statement here. So I'm just going to put a little comment here, case statement. And actually there should be a comma before that, but we'll get around to it, from language. So just to start off, I always like to just see what I'm dealing with. So I'm going to select everything from language. Let's use Sequila here. There we go. Now let's see if we have language. There we go. So here you can see that we just have a table with these different languages. And we want to know, basically, we're going to use a case statement to kind of fabricate some information. Case statements are really nice for doing ETL work, or you've probably heard about it. ETL stands for extract, which is really a select statement, getting data out of a system or a database, often both at the same time. And then you transform it, meaning that you take the existing data and we do something to it to make it so we can then load it into another application. So this is kind of like what we would be doing here. This is a good example of typical ETL work where, like, oh, we need to know what character set we're going to use for each language in this third-party system, or so on and so forth. So we need to build a statement that's going to generate that data. So to start off, like I said, I'm just going to rebuild this so we can then do the exercise. So to start off, we're going to build the simple expression, which is where we say case name. And really this is our switch, if you will. So name is a single variable fixed. And then we just say, hey, when name is English, then return Latin 1. When Italian, when name is Italian, then Latin 1. And we're going to do that so on and so forth. I'm going to just kind of cheat here just a little bit. Italian, French, the only languages that don't use it are Japanese and Mandarin. And they use UTF-8. There we go. All right, so basically it's going to go through because it's going to read this row by row. That's kind of how I like to think about it. It's going to go row by row and check these. So it's going to say, okay, row 1 is English. Okay, so when name, we're examining the name column. When it's English, then it's Latin 1. Okay, as soon as, and the one thing to remember with case statements, it can't be both, right? Because how does it return 2 values for a single column? So that's one important thing to remember is it can only be one of these. So as soon as it matches one, it breaks out. If you're used to other programming languages, that's it will break out of it. It doesn't continue to search. So in this case, row 1 is English, and it says, okay, we're Latin 1, done. And then Italian, so on and so forth. It'll go through, and so where these are mostly 1-to-1, it's going to return those. The last little bit of this is that it has a additional clause that says else. We can put like a block to kind of catch if anything else happens. And we go unknown to match it from language. And we can, the last thing we need is to end our case statement. So the format of this is you say case to kind of say, hey, I'm going to do some logic here. And if it's simple, then we put the variable that we're examining. And the thing that we have to, when simple, the difference between simple and searched is really when we're doing simple, we can't do any additional logic here. We just have to put when value, then value, if that makes sense. And then we get down here. If none of these match, then we say unknown, and then we use end to end our logic block, and then we can continue the query as normal. So let's go ahead and run this. And oops, I've made a mistake. Select name, case name. What did I do here?
You have a comma, very first thing before name.
Oh, yes. Thank you. And I misspelled. It's not a language, it's a language. There we go. All right, so there we go. And we want to name this column. You can see how this column name would be atrocious. So we're going to say end as character set. There we go. So at this point, we're matching the existing query, which is a simple one. So what the instructions say to do is to get the same results, but do it using a searched expression and try to use as few when clauses as possible. So I'm really going to take this to extreme, and we're going to keep it to as few as we can. And we're going to see the difference here between the simple and the searched. So this time we're going to say case and not put any value there. We're not going to put a column name because we're going to handle it inside of our when statements. And that's why they call it a searched versus simple. And the reason it's searched is because it's going to run each logic block individually, which is a little bit more intensive, but it's also way more powerful, which is why I said earlier, I think I said it earlier. I only really use searched case expressions. I hardly ever use simple just because it's most of the time simple won't work for the use case, and you'll kind of find that as well. But anyways, let's proceed. So the first thing that I'm going to take care of is actually my outliers. So Japanese and Mandarin are our 2 UTF columns. So I'm going to say when name is in Japanese And when we use a search case, we can build in all sorts of logic. So for example, I couldn't use in on these because it has to be a single value. But in this case, I can say when name is in Japanese or Mandarin, then let's use UTF-8. Else Latin 1. Now, the only caveat to my solution here is that if someone were to add another language, it would automatically be put into the Latin 1 category, which honestly, in my opinion, is just fine. So you can see here, we've got the same results, just we used a little bit different case statement. So anyways, and let's say we wanted to try to replicate that with this simple one, just to kind of show you how this doesn't work. Is let's say we wanted to take, and instead of saying when, Japanese, let's say we say when in Japanese. I'll get an error because this one can't handle like additional logic, if that makes sense. All right, the other thing we can do is we can actually tie things together. Like you could do like an and then more logic, or an or and then more. So you can see how they can get very, very complicated very quickly. I think I might have an example of one. Let me see if I have an example of a real life one here. Let's see if we can open. That is atrocious. Let's find it here real quick. Yes. All right, this one is in a Python file, but it should get the point across here. And of course, that one doesn't have. Anyways, we'll continue because we got more to show. If I come across it in the meantime, we'll do it. So anyways, that is exercise 1 that we just did. So we used it with a search expression and we used fewer clauses. So mission accomplished. All right, so now we're going to do question 2, and it says rewrite the following query so that the result set contains a single row with 5 columns, 1 for each rating. We name the 5 columns as such, and it has a count. So I'm just going to, let's see how well this copies and pastes here. On our rating. Let's go ahead and run this and just see what we get. Okay, so in this case, we get a bunch of rows. And if we look at what we want, is we want columns. So there's a couple different ways to go about this, but there's one kind of, like I said, case statements. Case statements can be really used in a hacky kind of a way, which is really kind of fun in a way, I guess you could say. So that's what we're going to do. We're going to kind of use this. So instead of having to do like all these joins, we can do a couple different things. So we're going to use our case statements. Let's see. So right now we have rating and account of everything from film by rating. And we're going to keep this pretty much just the same. The only difference, what we're going to do here is we're going to use a bunch of different case statements to achieve a join. We're actually going to go almost through the same logic as what we would if we were doing joins, but we're just going to do it manually. So I'm going to say case when rating, and let's see, at first we want G. When rating is equal to G, then we return the count of film. So in this case, I'm going to return, sorry, I'm having some bad habitual habits here. So basically what I'm doing here is I'm saying case when the rating is G, then it returns the film ID. But we're going to, like I said, we're going to hack this just a little bit. And I'm going to count distinct we're going to call that G-rated films. So basically, I'm doing the same thing as I was before. We were getting the count of everything, right? This was our total count. Basically, I'm doing the same thing, but inside of the count, because the count function just counts things. So we can put whatever we want in there. In this case, I am putting a distinct because it's implied because this is a primary key, but I like to put it there just so it's more readable and safe, because we only want to count distinct films. But in this case, the only ones that are going to get count, if you recall back when we went over aggregations and null handling and functions, the count function does not count null values. If we do count distinct case when rating is equal to G, then it returns the film ID. Basically, if we don't have anything else, it's going to be empty. So it's going to only count the G-rated film. So let's go ahead and run this. And you can see here that now in our little rows, we not only have a rating, but we have a G and a total. So we're going to continue this kind of method for all of our other ratings. So let's do PG and add our PG. Now we can see PG get a line. Next, we're going to do our PG 13. You can kind of see how we're going diagonal, and you're probably thinking, well, that's not the format that it's supposed to look like. And we are going to get there. That's rated R, not T. And then NC 17. Let's run this, and you can kind of see how all these tie out, which I kind of like, because then you can make sure, like, everything's working, even with our little hack we got going here. What I'm going to do is I'm just going to take out this rating. And then we're also going to take out our group by. And then we are left with our format. The reason we take out the group by is because we are no longer grouping it, because it's all one row. Really, we're counting everything. It's the same thing as doing a, we don't need a group by if we just do select the count of everything from film. We can do our count this way, and we don't need a group by clause. That's because we're not doing any grouping. The compiler or whatever's happening in the background doesn't need to know how it's going to bin our numbers, our aggregations. So in this case, it just says, oh, there is nothing to aggregate by, so just produce one row. So in this case, we have one row with all of our counts. Does anyone have any questions about this one? Okay, let's move on. All right, question 3. This is where this is where most people, I've actually already answered quite a few questions about question 3, 4, and 5, which is actually fun. These are some of my favorite questions because they're like little puzzles. Really like them. So, anyways, and I guess for people who wonder why they're kind of like puzzles, I think that they kind of do these kind of questions because you have to know how they work they make you think out of the box just a little bit, in the sense that you have to understand like how to use some of these things together. So anyways, we're going to write a query that returns the alphabetized first letter of the customer's last name, the count of the active and inactive customers by the first letter of their last name. So, pretty simple. We're just going to let's just start by getting everyone's last names, right? The first letter of their last names. So we want their last name, but only the first letter. So I'm going to do a substring of C dot last name, start at character 1, go 1 character long, and they call this starts with. So let's go ahead and let's just run this. So I'm going to get their first letter of their name, and just to kind of test here, make sure we're getting the results we expect, I'm going to do this. Okay, yep, looks right. We can see that we're just getting the first letter of their name. So now we can carry on, and now we want to get the active count and the inactive count. So we're going to say count case when C dot active is equal to 1, then 1. We could do that, or we could do, really what we probably want to do is do a sum. So let's sum these results instead of count them. We're going to say case when active is equal to 1, then we want to return a 1 because we're only going to count it one time. And we need our end as active count. And we could do a count, we can do a sum. It really doesn't matter too much either way. I did sum just because then that way it, it's going to collect them all essentially. Case when C dot active is equal to 0, then we count 1. All right, now, if we were to try to run this, we should get an error because we are using an aggregation like sum or count without a group by. And this time we do need a group by because we have this column here. So what we can do is we can just say group by starts with. And there we go. And you can see that it's all out of order. So we're going to say order by 1 ascending. And there we go. Oh, so interesting. One thing that we want to, when we do the sum, if it's null, so maybe this is a good reason to use count instead of sum. There we go. So count will give us a 0. So that's probably what we want to use instead of the sum. Because in MySQL, so if I did 5 plus null, it actually is going to return null, not 0. So yeah, in this case, we actually do want to use count. But anyways, that is question 3. Any questions there? On that one? Okay. So this one is where we're going to get a little tricky. So this one says write a query that returns the alphabetized first letter, basically the same thing. But this one has a little bit different. It says, but return results that include any missing letters from the data set. So if we take a look at this, you'll notice that we are missing some of the alphabet. We only have 23 records when there should be 26. Element like Q, R, S, T, U. We're missing a U and a Z, for example. So like we're missing some. So basically what it wants, the difference between 3 and 4 is we want to include those. And we want to do this in a programmatic way, because we could do like some manual lift for it, but we want this to kind of be very programmatic and work no matter what. So a couple options here. The first one being is we can build an alphabet table, if that makes sense. And we can fabricate that pretty easy. So I'm going to just real quick do an A G H I J K N O U R S T U V Z. Okay, so what I'm going to do is I'm going to do this in Visual Studio Code because I can kind of cheat just a little bit. So I'm going to replace all of my commas with select at the beginning. This because we're gonna okay. Now what I'm going to do is I'm going to find all the selects and replace it. I'm just going to go backwards a little bit. We're going to replace this with select. Base. Let's get a carriage return. Go ahead and replace all those. This all makes sense. We're going to go like that. And then we're going to find our quote space, and we're going to replace that with quote space letter union. All right, so now we have all these things here, and if we really wanted to, I guess we'll be correct. We're going to look for union, and we are going to replace it with union carriage return. No, carriage return union. Okay. Now we're getting somewhere. All right. So now we have this big giant select statement that we can use to basically create a table. Now we could create a table We could use it as a subquery. So let's just go over a couple of those options here. So if we were to take this and come here, we have our customer C, and I'm going to say, let's left join this. Actually, we want to left join the other way. So I could do a right join here, but I usually like to keep things pretty good. So we're going to left join that. So I'm going to take my letter subquery, paste that in there, which is a lot. We're going to call this LTR. And we left join that with customer on, and then this is where we take our existing logic for our first name, and we say where the first letter of the substring is equal to letter dot letter. And then, you know, we can say LTR dot letter. Now it looks like I have something going on here. Oh, did I miss a? We'll group by. Got that. And probably should say join. There we go. Okay, so that is one solution. And you can see now that we have all 26 letters of the alphabet. Now, as you can see that is, you know, really atrocious to say the least. You know, it's long, it's messy. So we can just say create table alphabet as. So we can use that same query, create a table alphabet. And so then we say select everything from alphabet. And there's our letters, from which then we could just say from alphabet, keep it all the exact same, get the same results. So that's option number 2, is where we actually use that same query to build a table. That's probably like the method that they're going for in the book and in the course. But I'm going to show you a hack, because when someone asks about this, I'm like, man, I know there's a better way, because I used to do stuff like this all the time. When I was at my other job, like I was fabricating data all the time, and I found all these little shortcuts and hacks. And so one of these is that we actually use an existing table to our benefit, in which case we just need a table that has at least 26 rows in it. And so in that case, I'm going to use the customer table because I know it does. And so what I'm going to do is I'm going to use a function called char, which basically builds a character based on a Unicode value. So what I'm going to do is I'm going to put customer ID in here, just, a simple customer ID. And there's this magical 64 number. And I'm going to say, call that the letter. And then I'm just going to select this from customer, where customer ID is less than or equal to 26, because we only want the 26 letters of the alphabet. So if I run this query, you'll notice that I magically get all 26 letters of the alphabet, which certainly is a lot less work than what we just went through. So again, from this, you could create a table, or we could use this as a subquery. In this case, I'm just going to use it as a subquery. So I'm going to take my from, instead of using the alphabet table, I'm going to build a little subquery here. Just going to paste that in there. And we have our letter. I'll run this, and voila, all 26 letters, and we should be good. That one's a little bit hacky, but it's also very cool. And like I said, all you need is a table that has at least 26 records in it. And basically the customer ID has to count all the way up. So like if an ID had ever been deleted, it obviously wouldn't work. But because customer ID just counted up through, then it works fine. So again, like this one isn't like one that you'd want to like keep that runs scheduled every day on a production server. But like if we're just generating the data to build the alphabet table, it works just fine. It's definitely simpler than trying to fabricate it yourself. Any questions on that one?
Not a question, but thank you, thank you. I was looking, I didn't want to put all 26 rows there. So thank you.
Yes. Yeah, this is kind of a fun little one. I really enjoy stuff like that. So it's pretty fun. The other option, there's lots of options, but anyway, so let's carry on to question 5 because we are running a little bit behind schedule. So question 5, it says write a query. Basically the same thing, but this time we only want it for the letters where the count of active customers is greater than 30. So basically we only want to see the letters of the alphabet who are greater than 30. So this one actually is very similar. Technically we could just use 4 because if they're not there, then they don't exist. And so in fact, let's actually do that. Did I ever save that other one? Apparently not. So I'm going to take this off because in this case, we don't care about having all the letters if they don't exist, because in this case, it doesn't make any sense to, we only want to see the ones that have over 30 active customers, in which case they wouldn't have, we wouldn't need that other table anyways, if that makes sense. So that's basically, yeah, so that's what we're going to do here, is go back to kind of our original. We're going to do this as starts with. So we're kind of back to our original where it doesn't have all of them, but like I said, it doesn't matter because what we're going to do is this is where this little having clause comes in. We're going to say having starts with, or not starts with, sorry, having an active count greater than, is it greater than 30? Yep, not equal to, greater than or greater than 30. So we can just do that and we get 8 rows in our set, just like we do here. We should match B, C, G, H, M, R, S, W. So question 5 is actually pretty simple because it's just question 3 with this little simple having clause. And just so you know, like if we really wanted to, we could take this and instead of using the alias, we could actually just build that in and we'll get the same results. But either way, questions on that one? All right, and that having clause is actually from the aggregation week, but we kind of go back through it a couple times. All right, and that is week 10 exercises. So let's jump into next week's stuff. And we're going to cover in week 11, we cover transactions. And transactions, I kind of gave a brief overview in the announcement, but transactions are really like save points. I like to think of them like save games. And that kind of stuff. So anyways, like just as a real quick kind of example, because these are really, actually, let's just do the exercises. So exercise 1, and this one we have to do a little bit more. So exercise number 1. Question 1, generate a unit of work We transfer $50 from account 123 to account 789. We'll need to insert 2 rows into the transaction table and update 2 rows in the account table. We use the following table definitions and data. So we have to build a couple of tables here. And I think we should only do this once. So I'm actually going to build these and I will share the code so that we don't have to do this over and over. But I'm going to create the table account. And we are going to have some columns in here. We are going to have a account ID. It is an int primary key and auto increment. We have avail balance, which is a double. And we have a last activity date, which is a date time, just like that. All right. There's that table. And next we need to fill, we need to fill that with some data. So let's say insert into account. We're going to insert into account ID, avail balance, and last activity date. And our values are as such. It's going to be 1, 2, 3, 500. And I'm actually just going to take and copy these dates. And really I should, let's just go like this. Doesn't really matter. So we're just going to go ahead and just cheat a little bit. All right, so they have $500 in their account and 789 has 75. That's a lot of movie rentals. $500, wow. All right, so now we have that data in there and let's create our transaction. Create table transaction, which I'm surprised they call that the transaction table because that is a reserved keyword. We're going to have a transaction ID. It's an int primary key, auto increment, transaction date. When did it happen? Which account? No, I'm not putting nominals in there. I probably should have done that. Since we're going to share this. There we go. Primary key. Transaction date is nullable, actually, which is surprising. Account ID is nullable. And transaction type CD is a varchar 1 length, which is not nullable. And amount, which is a double. Now, technically, when I'm doing doubles, I like to put a disclaimer there, but we're just going to leave it for now. All right, and there's that table. And we're going to put some data in that one. So we're going to say insert into transaction, TXN ID, TXN date, account ID, TXN type CD, and amount. And our first one is going to be 1003. we'll use these dates since they already have transactions. But we'll change this so it's current year. Make sure this is in the future. Yes, it is. Perfect. Because we don't want to have transactions before their accounts were created, if that makes sense. Account ID 123. It was a debit for the amount of $50. Counting 101 debits, credits. This one's going to be the same thing. So 79. And this one is credit. So we credited their account $50. Transaction. Oh. There we go. Okay. All right. So what we were supposed to do, we need to generate a unit of work to transfer $50. Oh, and that's actually what this just did. So we're going to take a break here and say delete from transaction. We're going to delete it all because this is actually what we want for our exercise. So if we go back here, it says we will have to build the account and transaction tables and put necessary stuff in here, but we want to generate a unit of work to transfer $50 from one count to the other. So I guess this is where we begin the lecture on our transactions. And I wish that they would have used a different kind of example because I don't want to get confused with the actual transaction table. But the main reason these exist is mainly for financial reasons, which we will go over. For example, let's say that we wanted to make sure that everything happened because let's say that we wanted to debit someone's account to put into another account. So like in this case, we're moving $50 from here into here. Now, what would happen, and I always like to use this analogy, let's say that you go to the store and you want to buy an item and you swipe your card and there's a lot of things that happen here. So they scan it, they say, yeah, it's going to be $50. They swipe your card, and let's say they took $50 out of your account, you swiped it, but let's say something happened like on the network side of things or software, and all of a sudden something broke and it says, oh, an error occurred. The cash register probably isn't going to let you walk with that $50 item. They're going to say, oh, your card didn't work or something, so on and so forth. But then let's say you get home and all of a sudden you look at your bank account and you realize, oh, I was billed for that $50. Odds are we've probably all been in a situation similar, or, and then you have to go try to deal with it, try to get your money back, and it's a huge pain. So you can see how that would be problematic. And that's where transactions come in. Transactions help us keep everything isolated and undoable. So they're used a lot in the business world, so you can kind of keep things going, but they're also very utilitarian, which we'll cover here in just a minute. So we kind of have all of our data here. So now what we want to do is make sure everything goes through. So for our unit of work, what we're going to do is we're going to say begin, or we're going to say save point, and we can give this a name. So I'm going to call this before, what is that called when you shift money around? Let's call it before transaction. All right, so we're going to create a save point, and then what we're going to do is we are going to do two things. I'm actually going to split these up. Right. So let's say that we're not using transactions right now. So I'm even going to comment this out. right? So let's say that I actually did mess something up like I did that first time, right? Where I had two of the same thing. So let's say I go to do an insert into transaction. It goes through. So I've just debited account 123 for $50. It hits here. Up, there's an error. Well, now all of a sudden I've got a mess, right? So then we have to delete everything from transaction, which we can do now. But you can imagine how difficult this would be if you're, let's say Apple, who's, doing a lot of transactions every day, and all of a sudden you have a ton that don't work. So what we're going to do is we're going to use the save point. We're going to create one. So save point before transaction. Oh, and one thing that we want to do, I'm going to kind of break this here real quick. I'm just going to say commit. Depending on what IDE you're using, you'll want to turn off auto commits. So a lot of databases, just to make it easier on people just doing things, you can turn on and off auto commits. So like mine, it's here, and you can see mine's on auto commit, which means whatever I do is going to be committed, which means made permanent. So what I'm going to do is I'm going to switch this to a manual commit. And now you can see some stuff changed, which we're not going to worry about because that's just all UI. So I'm going to create a save point before transaction. I'm going to run this. It worked. I'm going to run this. Up, something broke, right? So I'm going to select everything from transactions just so we can have some visibility in here. And there's only one record. Now, I just want to undo everything, right? Because let's say there's 100,000 more rows in here. I don't want to try to find which one was the bad one. So what I'll do is I'll just say roll back to before transaction. And let's select again. And it's gone. Right? So really, like, kind of the way the logic would work here. If something bad happens, we roll back to transaction. If everything works, we commit. So let's walk through that again one more time. I'm going to put this here. So I'm going to create a save point. And let's actually commit real quick just to make sure we're all cleaned up. I'm going to create a save point before transaction. Try to insert. Try to insert. Oops, it broke. If something bad happens, we're going to roll back. And it's like it never happened, right? Now let's fix our error. We're going to do again. We're going to do our save point. Do our insert. Do our insert. Everything worked properly. We can even look, make sure it did. And then commit. And once we commit, things are permanent. Because let's see if you'll notice that if I try to roll back after I commit, it says save point before transaction does not exist. So at this point, you're kind of in trouble, if that makes sense. All right, and so that is our unit of work. Basically this right here. This would be our, let's give it a name. Basically our little logic flow. All right. That's just questions, questions, and questions, which isn't too crazy, but let's go over them. So question 2, a web-based program that you're using uses inserts into member, customer address, and telephone tables in separate statements, which the programmer felt was equivalent to a transaction scope. And what they mean by a transaction scope is when I create a transaction or a save point, it's everything that I do within that scope or that transaction is now isolated, meaning if I roll it back, it's going to undo everything. If I commit it, everything that I just did within that scope is now permanent. The web-based program leaves the auto commit setting on before inserting into the records. Set auto commit equal 1. After inserting and committing values into the member and customer table, the insert fails to write to the address table and then attempts to undo all inserts made by the transaction. Which of the followings contain data you can't undo with a rollback command after the failed insert into the address table? I'm just going to real quick. It's just going to submit it. Anyways, in this case, since auto commit is 1, everything we run is going to be permanent immediately. So if auto commit is on, it's committing everything as you run it, meaning if I execute a command, it's permanent. So in this case, he's inserted into member and customer, but the insert into address fails. So at this point, member and customer are the only ones that have been inserted into. We can't roll back because auto commit was on. So at this point, member and customer are permanent, and we would have to then fix them manually. Any questions on that? Okay. Question 3 looks like it's going to be the same thing, but this time we disabled auto commit. So this time we disabled auto commit and we've inserted some things, and then we do a rollback. Fails to write into address. Which of the following tables contain data you can't undo with a rollback command after the failed insert into the address table? So auto commit is off, meaning that basically in this case, we can roll back all of the changes: member, customer, address, and telephone. So in this case, none of the above. Any questions on that one? Does that make sense? 2 and 3. Because auto commit is off, we are not committing after each run. So basically everything is rollback. We could roll back if we wanted to, except for deletes or truncates. You can roll back a delete. You cannot roll back a truncate. All right. And so this is a stored procedure, meaning that it is a function, basically kind of what we were doing before. You can see how this is kind of how the logic works. So we can kind of ignore this because these are just parameters. So we can kind of just ignore this, and we're going to start here. So in this exit handler is basically if it catches an error. It says declare an exit handler when a string is too long for a column, right? So basically if someone tried to put in 60 characters into a varchar 30, this is going to run. So that's just kind of conditional. Auto commit is equal to 0, meaning it's disabled. And we start our transaction. We insert into all of our stuff. Now, let's say that this one's too long. It's going to roll back. So it says after inserting into the member and customer table, the insert fails to write to the address table and attempts to undo all inserts made by the transaction. Which of the following tables contain data you can't undo with a rollback command after the failed insert? And again, this one's the same as above. It's actually none of the above, because if we're going through here, it inserted into member and customer, but it failed here. So in this case, it rolled back already because it never hit commit. You know, it errored out, this caught it, and it rolled it back. All right, in question 5, I'm going to let you answer this one because it is it's more just like a kind of a fun one. So I'll let you guys answer that because I want to read it. But I do want to real quick, just in like 5 minutes, cover a couple additional use cases for transactions. Because honestly, like I don't think any of you are probably going to go out and build a banking something right out of the gates, right? There's lots of stuff to go there. So what I use transactions for most of the time is actually for my own benefit. And I'll show you exactly what I mean here. So let's take a look at customer. from customer. So this is a pretty common thing. Let's say that someone calls and said, hey, you know, we need to change so-and-so's email. Or, you know, we need to fix some bug in the system. In this case, we're just going to fix someone's email, right? And they say, hey, or let's use this as a use case. Everyone has an @sequilacustomer.org email address, right? Let's say that we want to change that because we're changing our domain name. We just want it to be sequila.org. Or let's say we're not doing Sequila anymore. Let's movies.com. Let's say instead of being sequilacustomer.org, we're going to be movies.com. And they say, we want to change everyone's email from sequilacustomer.org to, you know, I can't remember, movies.com. So we're going to say update customer set email equal to, and then this is where we need to do some work to figure out, you know, how we're going to do this. So I'm going to real quick do a replace, and we're going to replace email. We're going to replace @sequilacustomer.org with @movies.com. And we're going to do this for everybody, right? So I'm not going to put a where clause, but you know, I could just run this, but there's a lot of risk. So let's say I accidentally delete everyone's email. Like, let's say that I'm not thinking and I do something along the lines of this. I set email equal to, because I mean, honestly, you're working all day, your brain does some pretty weird things. Movies.com. Right. And again, a lot of times we're doing this on production data. Now, normally I would say even do some more checks, like actually write a query to see what the result of this is going to be. Like so. Like I would recommend that anyways, because we can see that it's working here. But let's say that I were going to do something bad. Now I'm actually going to create a save point for the same reason that I normally would. I'm going to call this save point save me. So I'm going to create a save point, and let's say I run this update statement, and then I say, oh yeah, let's see if it works. Uh-oh, I just lost everyone's email address. I mean, and the thing about working with databases is it's very quickly, this could get me fired territory. So you always want to make sure you have backups. But the second thing is you always want to make sure you use transactions. Because I did this transaction without having to spend hours doing a backup, losing data and all these other things, I can simply roll it back. And whew, see, that saved me a lot of headache, possibly my job. So save points are really nice. So before I do any changes, like update statements and the like, I always do a transaction. So I do save point. I'm just going to call working one. I'm going to update. And then I'm going to check my results. Because it doesn't always have to be programmatic, so to speak, you know, like the transaction example. In this case, it can be as simple as, oh, you know, like I just want to try something and verify results before I do this. And, you know, if I look at this, you'll notice that there's this sequilastaff.com. So that one didn't get fixed. But, you know, at this point where I got the bulk of them, I'm just going to say, yeah, that looks good. So I did my save point, I updated my data, and now I'm going to commit now that I've verified that everything worked the way I expected it to. So now we're all fixed. Does that make sense to everybody? What we just did there?
Yes.
Perfect. Perfect. Well, that's actually all I had. I think, like I said, should be some pretty light weeks, especially where we did the exercises. And I'll just say this, as far as your papers go, in next week, I'm completely okay with just doing the bare minimum. It doesn't need to be anything fancy. Because I understand that there's really only like 2-3 weeks of actual school days. So, I didn't know like how I could like reduce the workload besides just reducing it, because I can't necessarily just like take out assignments. So anyways, just do the bare minimum on your papers, and yeah, hopefully this helped save you some time on the exercises as well. But if no one else has any questions, I hope you have a great week. And if something comes up, feel free to shoot me a message.
Thank you.
Yeah, no problem. Thank you.